In the previous two videos, we established that n is equal to n naught e power minus lambda t, where t is the duration in which n naught number of nuclei became n. So this n stands for number of nuclei left undecayed, and this is the original number of nuclei, original number of radioactive nuclei. So n is equal to n naught e power minus lambda t. The other one was t half, or half-life is 0.6931 by lambda, where this lambda is called decay constant, or probability per unit time, probability of disintegration per unit time. So now let us write the first equation like this. So the first equation became n, bring n naught down here, n is equal to n naught e power minus lambda t. But from this relation, lambda is 0.6931 by t half. So let us substitute it over there. So what this n by n naught represents, we will discuss about it now. Minus lambda. So instead of lambda, we are going to substitute what lambda is 0.6931 divided by t half into total time t. So n by n naught equal to e power minus 0.6931 into t by t half. What is total time by half-life? Total time by half-life is number of half-lives. For instance, a radioactive element has 4 days of half-life. 4 days half-life. Suppose in 20 days, how many half-lives are there? If that is there, so 20 by 4 will give you 5. That means 5 half-lives are there in 20 days. So this one is called number of half-lives. So n by n naught is equal to e power minus 0.6931 whole power n. So this one, let us bring down. So this becomes 1 by e power 0.6931 whole power number of half-lives. So n by n naught. So we are going to discuss about two things right now. So the first part, let us look at this. We know that natural logarithm of 2 is 2.303 into log 2 to the base 10. Then log 2 is 0.3010. When you multiply, 0.6931 is what we got. This is natural logarithm of 2. When you raise to power e now, e power natural logarithm of 2 equal to e power 0.6931. E and natural logarithm are inverse, they cancel out. So 2 equal to e power 0.6931. So e raised to 0.6931 is actually 2. So this can be written as 2. So n by n naught is equal to 1 by 2 whole power n, where n stands for number of half-lives of a radioactive sample. And this one is a very important one. This is called fraction left. Fraction of radioactive nuclei left. If they ask you percentage of radioactive nuclei left, it is simply into 100. So how does this work? In a class of 10 students, if 8 students pass, in the exam, pass percentage is 8 by 10 into 100. That means 80%, meaning out of 100 students, 80 students passed. When you divide by 100, what you get, for every one student, how many got passed? 0.8. Similarly, so the number left by n naught is fraction left. So n by n naught is called fraction left. N by n naught is equal to fraction of nuclei left. What is fraction decayed? So usually here if pass percentage is 80%, passing fraction is 0.8, then fail fraction is 0.2. So 0.8 plus 0.2 is always 1. That means passing fraction plus failing fraction is always is equal to 1. Similarly, fraction left plus fraction decayed is always is equal to 1. If n by n naught is fraction left, 1 minus n by n naught is percentage left. So this one I left unwrapped. So let me just clear this. So now n by n naught is fraction left. 1 minus n by n naught is fraction decayed. A very useful formula is suppose. So what is the percentage of, suppose if I am asking a question, percentage of radioactive sample left after 3 half-lives, then n by n naught is fraction left, then percentage left is into 100, but n by n naught is actually 1 by 2 whole power number of half-lives. How many half-lives they are talking about? 3. That means 1 by 2 cube, that means 1 by 8. So 1 by 8 is a fraction left in, so they are talking about number of sample left, so percentage left. So percentage left means into 100. So after 3 half-lives, only 12.1 by 8 into 10 is, when you cancel this out, 12.5 percentage. How is that? Suppose you start with 100 percentage of the sample. Then after 1 half-life, 1 t half, the remaining will be 50%. Then after 1 more t half, remaining will be 25%. Then after 1 more t half, 1 half-life, percentage left will be 12.5%. Hence, after 3 half-lives, percentage left is 12.5. Percentage decayed is 1 minus 100 minus percentage left. Percentage left is 12.5. Then percentage decayed. So percentage decayed equal to 100 minus 12.5, that is 87.5.